Let's solve few problems based on tangents and normals. You know, the concept, whatever we have learned so far. All right. See the problem. The first one, find the slope of the tangent to the curve. This is given at x is equal to 4. So always tangent and normal will be given or it will be asked for a particular point. Okay. See the first one. You have first differentiate, guys. No, so directly we'll start with the problem. All right. So we have dy by dx at x is equal to 4. Okay. So you'll have 12x cube minus 4. Isn't it? This is the derivative. So this will become 12 into 4 cube minus 4. Or you can take 4 common. 12 into 4 square is 16 minus 1. Or 4 into 12 times 16, correct? So you will have 12 into 6, or you can do 16 into 2. 16 into 2 is 32. Then you have 90. 192 minus 1. 4 times 191. So you are going to have this as 4, 3, 7, 764. So the slope of the tangent at x is equal to 4 for this curve is 764. It's pretty high. I mean, it's quite very high actually, honest. All right. So this is the answer for the first one. Now, very similar to it, we have the second one. Okay, so let's do the second one. See the second one. Find the slope. Again, dy by dx or y dash is equal to 3x square minus 1. What is the point? X is equal to 2. Substitute. 3 into 2 square is 4 minus 1. So 12 minus 1 is 11. So the slope of the tangent is going to be 11. So this is the answer for the second one. Very simple, very direct. Correct? Let's do the third one. All right. The third one, it talks about the slope of the normal. See, first find the slope of the tangent. Then we do negative reciprocal to get the slope of the normal. Fair enough? So here we have first dx by d theta. This is going to be 3a into cos square theta into minus sine theta. Remember, we have to use that this one, the chain rule, to get this done. So this is dx by d theta. Dy by d theta. This is going to be 3a sine square theta into cos theta. Correct? Now dy by dx. Remember, you used to do this in parametric form. Divide one by the other. That means you have 3a sine square theta cos theta divided by minus 3a cos square theta into sine theta. 3a cancels, one sine cancels, and then one cosine also cancels, correct? So you finally end up with minus tan theta. What is the value? So theta value is pi by 4. If you take theta as pi by 4, so you have minus tan pi by 4, isn't it? So what are we doing here? We are substituting this theta as pi by 4. So you will get the value as minus 1. Now, slope of the tangent is negative 1, isn't it? So you can say m slope of the tangent. Tangent. This is minus 1. So what will be the slope of the normal? Negative reciprocal, which is nothing but 1 itself, correct? So m of normal will be equal to 1. So final answer is going to be 1. That's all. Always to find the slope of the normal, first find the slope of the tangent, then do negative reciprocal. Fine. The fourth one is pretty much the same. So now I think you guys can go ahead and you can try it. All right. Now let me also do the fourth one. All right. See the fourth one, slope of the normal again. So differentiate with respect to theta. Dx by d theta is equal to, so you have minus a cos theta. and dy by d theta will be equal to 2b cos theta into minus sin theta, isn't it? Again, the divide dy by dx will be first minus 2b cos theta into sin theta over minus a cos theta. Cos theta cancels, minus minus cancels, correct? So you end up with 2b by a into sin theta. This is the slope, but slope in the sense the derivative. Now we'll substitute theta as pi by 2. So if you take theta as pi by 2, so sin pi by 2, 1, right? So this is going to become just 2b by a. So remember, here you're substituting theta as pi by 2, isn't it? So 2b by a. So we got the slope of the tangent, correct? So we'll call this value as, let's say, m1. If the slope of the normal is m2, then we have m1 into m2 is -1, right? So what we have, 2b by a into m2 is equal to -1. So what is the value of m2 then? Or the slope of the normal, what we call. So m2 is equal to minus a divided by 2b. So this will be the value, or you can say the slope of the normal. Fine. So now we'll do the next problem. All right. So we'll do the fifth one. The fifth one, find points at which the tangent to the curve is parallel to the x-axis. Okay. Now a very important point. So we are dealing with straight lines and coordinate geometry concepts, isn't it? So you need to recap all these things. Whenever you have a line, or whenever x-axis or any line parallel to x-axis, the slope of that particular line is going to be 0, correct? Slope of the line, any line parallel to the x-axis is going to be 0. That means the derivative should be equal to 0, right? Let's solve this one now. So we have the fifth one. First, y dash is equal to 3x square minus 6x minus 9. Since the line, the tangent, whatever we have, that line is parallel to the x-axis, the slope, that is dy by dx, is equal to 0. Let me repeat why it has to be 0. Any line parallel to x-axis or x-axis itself, the slope is always equal to 0. Alright, that's the reason why we are taking it like this. So, equate y dash to 0. You get 3x square minus 6x minus 9 is equal to 0. Now, don't you think this is nothing but, or take 3 common if you want. So, 3 into x square minus 2x minus 3 is equal to 0. See, you can divide by 3, right? That means you end up with x square minus 2x minus 3 is 0. Which you can split. The splitting of the middle term can be done, right? So if you're splitting, what we can do here, you can write this as minus 3 plus 1. In the sense, x minus 3 into x plus 1 is equal to 0. Or two values you have. What are the two values? You get x is equal to 3 or x is equal to minus 1. So these are the two values, because they're asking for find the points at which the tangent, right? Find the points. So what are the points? One is 3, one is minus 1. Now these are not the complete points because these are just the x coordinates. Substitute those x values in the equation and we need to get the y value also. Understood? So first, let's substitute x value as 3. If you substitute x value as 3, you will get the y value as minus 20. Okay. Now, if you take x value as minus 1, see, you will get minus 1 whole cube, which is minus 1, minus 1, minus 3 plus 9 plus 7, correct? Which is going to be minus 1 minus 3 is minus 4 plus 9, which is 5. 5 plus 7 is 12. So here y is equal to 12. So in other words, the final answer you can call it as 3 comma minus 20 and minus 1 comma 12. These are the answers. Fine. Or these are the points. Rather than saying these are the answers, these are the points. Fine. Now let's do the sixth question. Find a point on the curve at which the tangent is parallel to the chord joining these 2 points. Now you don't need the entire equation. You just need the slope of the line, because you know that parallel lines have the same slope, right? So first thing what we'll do, we'll calculate the slope between these 2 points. Let's call it as M2, or let's call it as M1, whichever you prefer. So for the sixth one, so the 2 points, let's call it as A 2 comma 0, B 4 comma 4. So the slope between them is 4 minus 0 divided by 4 minus 2, 4 by 2, which is equal to 2, right? So call this as M1. Now the derivative of our function should have a slope of 2, correct? Because they're parallel, isn't it? Now y dash becomes 2 into x minus 2, because it's x minus 2 whole square, 2 into x minus 2. This value is equal to 2, isn't it? So what you have, 2 into x minus 2 is equal to 2. Now again, let me repeat why it's equal. Because they're saying the tangent is parallel to the chord. So any line or lines which are parallel to each other, they have the same slope, isn't it? That's why we are taking it like this. Fine. Now cancel off the 2 and 2. So x minus 2 is equal to 1. So you get x is equal to 3. Now x value is 3, isn't it? Now you need to substitute for the y value. So if you substitute, y is equal to 3 minus 2 whole square. So y value is 1. Therefore, the point is 3 comma 1. This becomes the value. Understood? And this is the answer for the sixth question. Now let's do the seventh one. And the seventh one. Find the point on the curve y is equal to so much, whatever we have, at which the tangent is y is equal to x minus 11. Now let's calculate the slope of the tangent, because slope of the tangent is nothing but the derivative. Much easier to solve rather than solving these two equations, which is, of course, it's going to be a huge thing. Rather than that, differentiate, get the answer. It's much more easier. Okay. Now the slope of this tangent, it's always, you know, that y is equal to mx plus c, correct? And here we have y is equal to x minus 11. So this implies m is equal to 1, isn't it? Or you can say m1, just to be a little sure about it. So m1 is equal to 1. Now the next thing what you do, you differentiate this function. Because when you differentiate the function, what you are going to get is the slope of the tangent, correct? Isn't it? So if you differentiate this, you are going to get y dash is equal to 3x square minus 11. Now, when you have 3x square minus 11, equate this to 1, because the slope of the tangent is given to be 1. So 3x square minus 11 is equal to 1. 3x square is equal to 12. Or we can write x square is equal to 4. So x is equal to plus or minus 2. So we have 2 points, plus 2, minus 2. Let's substitute the values and get the value of y, right? So if you have x is equal to 2, then y value will become, so 2 cube is 8, 8 minus 22 plus 5, correct? Or you can say 22 or 13 minus 22, isn't it? So when you have 13 minus 22, it's going to be minus 9. This is 1 point. Or if you have x is equal to minus 2, then substitute minus 2, you get minus 8 plus 22 plus 5, correct? Or if you are going to take it, minus 8 plus 5 is minus 3, minus 3 plus 22 is going to be 19. So we are going to have 2 points here. Okay, so when you have 2 points, another point what you should understand is that of these 2 points, which is going to satisfy this particular tangent? Understood? Because that is going to be the point on the curve. That's why. So substitute x value as 2. That means now we are considering the equation of the tangent. So let me write it here. Y is equal to x minus 11. Substitute x as 2. Y is equal to 2 minus 11, which is minus 9. Well and good, it satisfies. Correct? It satisfies. So this point we can keep into consideration. Suppose if you are going to put the second point, that means here what we are doing is value as minus 2. Minus 2 minus 11 gives us minus 13. It is not giving 19, isn't it? That means we can discard this value because it is not a part of the tangent. So the curve and tangent touches at only one point, isn't it? And that point of contact is 2 comma 9 minus 9. That means therefore the point is 2 comma minus 9. So answer becomes 2 comma minus 9. Fair enough. So please do not stop at those 2 points. You need to find the point which is actually on the curve, which is touching the tangent. So the answer becomes 2 comma minus 9. So let's do the next question now. Find the equation of all lines having slope 2 which are tangents to the curve y is equal to 1 by x minus 3. Alright, first is you differentiate. Okay. Y dash will be equal to, see, you can take it as, okay, or rather than y dash, I think I can start with y, saying 1 by x minus 3 or x minus 3 power minus 1. Correct? So y dash becomes minus 1 by x minus 3 whole square. Isn't it? And this value is nothing but 2 because the slope is 2. Since the slope is 2, now what we are going to do? So minus 1 by 2 is equal to x minus 3 whole square. Now x minus 3 whole square is equal to minus 2. So what we have here is that the square of a particular number, I'm getting it as minus 2, isn't it? Now square of a number can never be negative, isn't it? Because you know square numbers are always positive. That means here we need to consider it in a different point of view, because 1 by x minus 3 is basically a discontinuous graph, correct? That way at x is equal to 3, it is going to be discontinuous. Now they're asking, find the equation of all lines having a slope of 2 which are tangents to the curve given by this one, right? So when you directly do it, you won't be able to do it. So you need to think of another way, and then you need to substitute and solve the equation. All right. So let's do that part right now. Get here is that x minus 3 or x minus 3 is equal to root of minus half, correct? Now the method what we are going to do is proving by like not even proving by contradiction. Directly you can tell. That is x minus 3 is equal to root of negative half, which is not at all possible, correct? So what we can tell here is that there are no tangents with slope of 2 for the given graph, or you can say for the given function, because You cannot have root of a negative number. So that's it. That's the answer for the 8th question. Okay. Let's do the 9th one now. Let's do the 9th one now. Okay. So let's differentiate the 9th one first. So y dash is equal to, again, guys, I'll take this as x square minus 2x plus 3 whole power minus 1, just like what we did in the previous one. So you'll get minus 1 by x square minus 2x plus 3 whole square into 2x minus 2. And this one has a slope of 0. This is possible only when the numerator is 0, correct? That means 2x minus 2 is equal to 0 or x is equal to 1. See, x is 1. Find the equations of all lines having a slope of 0. X is equal to 1. Substitute and get the value of y. That means y value becomes 1 by 1 minus 2 plus 3, correct? So which is 4 minus 2, 2. Y value is half. So what do you have? You have y minus y1 is equal to m into x minus x1. So y minus half is equal to 0 into x minus 1. 0 into anything is 0. So what do you get? Y minus half is equal to 0 or y is equal to half. Or in other words, you can also write 2y minus 1 is equal to 0. So this is going to be the equation. Basically, it is a line which is parallel to x-axis. That's all. Okay, so this is the answer for the 9th one. Here you have multiple sub-questions, correct? Question of both tangent and normal to the given curves. So let's do the first one. Y is this at 1 comma 3. So differentiate. You have 4x cube minus 18x square plus 26x minus 10. Substitute x as 1 because x is equal to 1, no? So 4 minus 18 plus 26 minus 10, which will be nothing but 30 minus 28, 2. 2 is the slope. Slope of what? Tangent. So y minus y1, 3, m into x minus x1. So you will get it as 2x minus y plus 1 is equal to 0. So this is the equation of the tangent. Alright, so 2x minus y. So 3 goes this side. So 3 minus 2 is 1. Now slope of the normal. So the normal part you can say m will be equal to, or m2 will be equal to minus half, isn't it? So you'll get y minus 3 is minus half into x minus 1. So now you can write this as x plus 2y because the 2 goes that side, and x you can take it here. Alright. So x plus 2y, so minus 6, and then it's going to become minus 1. Minus 7 is equal to 0. This is going to be the equation of the second one. Clear? So this is the answer. Now let's do the second part, which is y is equal to x cube. See here you have first y dash will be equal to 3x square. Now once your y dash is equal to 3x square, substitute x as 1. So when you substitute, slope m1 is equal to 3, right? So y minus y1 is equal to m into x minus x1, or you get 3x minus y minus 2 is equal to 0. This is the answer for the first one, as in the slope of the, equation of the tangent. Now equation of the normal. For that, let's first find the slope of the normal. Yeah. So slope of the normal, m2 will be equal to minus 1 by 3, right? So you get y minus y1 is m into x minus x1. So this is going to become x plus 3y minus 3 and then minus 1, which is going to be minus 4, is 0. See, this is the answer for the second sub question. Now let's do the third one. Question. First, do dx by dt. Remember the parametric form, whatever we were doing. Same thing. Dx by dt is going to become minus sine t. Dy by dt is going to become cos t. Correct? Now differentiate, sorry, as in divide one by the other. Dy by dx becomes cos t divided by minus sine t, which is minus cot t. Correct? Put t as pi by 4. So you'll get dy by dx is equal to minus 1. So slope of the tangent is minus 1. When you have slope of the tangent as minus 1, you get y minus y1. So you need the x and y value, right? Put this t is equal to pi by 4 here and here. You'll get the value of x and y. That means x value is going to be 1 by root 2. Y value is going to be 1 by root 2. Right? So you have y minus 1 by root 2 is equal to m, which is minus 1 into x minus 1 by root 2. Correct? So you're going to have x, take the value of x this side. So x plus y minus, or you can take it the other way around, is equal to 2 by root 2. Or you can also write it as x plus y is equal to root 2. Understood? So this will become x plus y minus root 2 is equal to 0. Now this is the slope of the tangent. Now we'll do the slope of the normal. Slope of the normal will be plus 1, correct? So slope of the normal is plus 1. Normal is going to be 1. So you have you have y minus 1 by root 2 is equal to 1 into x minus 1 by root, which basically, see, minus 1 by root 2 gets cancelled. That means you'll get x is equal to y or y is equal to x. Fair enough? So this is the normal equation. The previous one was the tangent equation. Alright, now let's do the 11th one. See the 11th one? See, show that the tangents to the curve, this one, at the points where x is equal to 2 and x is equal to minus 2 are parallel. Basically find the slope and put x as 2 and minus 2 and show that they are equal. Alright. So here what we have is first y dash is equal to 21 x square. That's all. Alright. Now first let's put x is equal to 2. So if you take x as 2, you'll get y dash is equal to 21 into 2 square, which is 4. Let's keep it at 21 into 4, or if you want, you can write it as 84. That's also fine. Okay. So let's call this as M1. Now what we'll do, we'll take the second one. That means same y dash is still 21 into x square itself. But now x value is minus 2. Correct? Put x as minus 2. 21 into minus 2 whole square. Alright? So 21 to minus 2 whole square is what? 21 into 4. That means you get 84, which is M2. So M1 and M2 are equal. If the slopes are the same, then we can say that the lines are parallel, isn't it? So the tangents are parallel. So you have to write the concluding statement that since the slopes are equal, the tangents are parallel to each other. Understood? Now let's do the 12th question. All right. See the 12th one. You have find the points on the curve at which the slope of the tangent is equal to the y coordinate of the point. Okay. So we need to solve this in a particular fashion. Yeah. First, let's differentiate. You get y dash is equal to 3x square. This is quite easy to understand. Now the slope is equal to the y coordinate of the point, correct? Now 3x square is the y dash value. This value is equal to y, the y coordinate of the point, right? But what is y? Y is equal to x cube. Substitute y as x cube. That means you get 3x square is equal to x cube. Cancel. X value is 3. So when you have x value as 3, substitute x as 3 in this equation. Alright. You get y is equal to 3 cube, which is 27. That means the slope, find the points on the curve. Y is 27, x is 3. So final answer becomes therefore the point. The point is 3, 27. This is going to be the final answer. So this is the answer for the 12th one. Alright, now let's do the 13th question. Alright. See, the question is, find the points on the curve at which the tangents are parallel to x-axis. Again, parallel to x-axis, the slope is going to be 0. Correct? Let's differentiate, but this, you can take the y square that side, you can solve it in multiple ways. So what I would do here is, first I'll take the y square is equal to 2x plus 3 minus x square. Transfer everything to the RHS. So 2y into y dash is equal to 2 minus 2x. Correct? So y dash is equal to 2 minus 2x divided by y. Now they're saying tangent is parallel to the x-axis. So the slope should be 0. That means y dash value is equal to 0. In other words, we can say 2 minus 2x is equal to 0 or x is equal to 1. Correct? Since x value is 1, what will we put now? Substitute this x value as 1 in the given equation. Yeah. So you're going to get here y square is equal to 2 plus 3 minus 1. Correct? So 2 plus 3 minus 1, y square is equal to 4. Y is equal to plus or minus 2. So we have two values for y and one value for x. So basically we can say the points. The points are 1 comma 2 and 1 comma minus 2. So these are the points. Clear? So these are the 2 points where the tangents are parallel to x-axis. Let's do the next one now. See the 14th one. You have find the equation of the normal at the point for the curve. Differentiate, get the value of the slope of tangent. Yeah. So you have ay square. So we'll do one thing. Y square is equal to 1 by a into x cube. It's easier to do it. That's all. So 2y into y dash is equal to 3x square divided by a. Yeah. Or y dash is equal to 3x square divided by 2y into a. Now x and y coordinates they have given. X is a into m square. Y is equal to a into m cube. Correct? So what we can substitute now, y dash is equal to 3 into am square whole square by 2a into am cube. Correct? So if you substitute, y dash is equal to 3a square m power 4 by 2a square into m cube. A square cancels, cancels. So this is going to become 3m divided by 2. See, 3m by 2 is the slope of the tangent. What you need is the slope of a normal. So reciprocate and put the negative sign. So slope, this is nothing but m1, you can call it the slope m1. So now you have m2 is equal to minus 2 by 3m. So minus 2 by 3m is going to be the slope of the normal, right? Since this is the slope of the normal, y minus y1 is m into x minus x1. So y minus am cube is equal to minus 2 by 3m into x minus am square. Cross multiply. So you're going to get it as 3 or 3m into y minus 3a m power 4 minus 2x plus 2a m square. So you'll get 2x plus 3my is equal to 2a m square plus 3a m power 4. Now on the RHS you can take common and you can simplify. Alright, or if you want you can keep it as it is. Even if you are going to take it common, you can take am square as common. You are still going to get it as this itself. So the final answer you can keep it as it is. So this you can keep it as the final answer, not an issue. Fine. So this is the answer for the 14th one, right? Let's do the 15th one now. See the 15th one. You have find the equations of the tangent and normal to the parabola at these 2 points, correct? Now first differentiate. 2y dash is equal to 4a, right? So y dash is equal to 4a by 2y. Substitute the point 2at, right? So you're going to get y dash is equal to 4a by 2 into 2at. 2 into 2 is 4. A cancels, so you'll get 1 by t. 1 by t is the slope of tangent. So let's call this as m1 is equal to 1 by t. Yeah. Now substitute the points. The point says at square, 2at. Let's find the equation of the tangent. So you have y minus y1, y minus 2at is equal to 1 by t into x minus a t square. Yeah. So you will get yt minus 2at square is x minus at square. So you can have this as x minus yt. The 2at square comes this side. So it's going to become plus at square is 0. See, this is the equation of the tangent. Okay. Now we'll do the equation of the normal. So for normal slope, m2 is equal to minus t, correct? So y minus 2at is equal to minus t into x minus a t square. Or you can write this as xt plus y, you can take it on the other side, is equal to at square plus 2at. Or you can write this as xt plus y is equal to, you can take at as common. So at into t plus 2. This you can write it as the equation of normal. So we have the tangent, we have the normal. Fair enough? Now let's do the next one, next question. See the 16th problem. Here you have find the equations of the tangent and normal to the hyperbola at point x naught comma y naught. This is supposed to be x naught and y naught. All right. Again, differentiate, we'll do the part. All right. So you will have 2x by a square, 2y into y dash by b square is equal to 0. Correct? Or you can write 2y y dash by b square is equal to 2x by a square. 2 and 2 cancels, right? So y dash becomes x into b square by y into a square. Substitute the value of x naught and y naught. So you'll get this as x naught b square by y naught a square. So this is going to be the slope of the tangent, which is m1. Yeah. Now, so once you have this m1 value, y minus y1, which is y minus y naught, is equal to x naught b square by y naught a square into x minus x naught. This is the general equation of a line, correct? Y minus y1 is m into x minus x1. Direct substitution, nothing more, nothing less. All right? Cross multiply. So you will get y naught a square minus y naught square a square, correct? Is equal to x naught b square minus x naught square b square. Take a moment and try to understand how this multiplication is being done. Cross multiply y naught a square and then y naught square into a square. Same thing on the RHS also. Now, there is nothing common, there is now no simplification whatsoever, right? So you can just take it as x naught b square minus y naught a square is equal to, or you can take it the other way around. In the sense, take the y naught a square on this side. So plus y naught square a square minus x naught square b square is equal to 0. This it will be the equation of the tangent. See, you might be saying that why can't we write this as a plus b into a minus b? In the sense, this part, you can write it as a plus b into a minus b. But to be honest, it doesn't make much of a difference. You might as well just write this as and this as the answer. All right. Now let's do the normal part because we have done the tangent. Now we'll do the normal. The slope of the normal. So m2. This is going to be y minus y naught a square by x naught b square. Correct? Negative reciprocal. So you're going to have y minus y naught minus y naught a square by x naught b square into x minus x naught. Correct? Multiply. So you will have x or y into x naught b square minus x naught y naught b square is equal to minus x into y naught into a square plus x naught y naught a square. Yeah. So take everything to LHS. So you can have x into y naught a square plus y into x naught b square. First part minus x naught y naught a square minus x naught y naught b square is equal to 0. Now we can take x naught y naught as common, right? So you'll get x into y naught a square plus y into x naught b square minus x naught y naught into a square plus b square is equal to 0. So this becomes the equation of the normal. So the previous one was for the tangent, this one is for the normal. Fine. Now we'll do the next one, which is the 17th question. All right. See the 17th one. Find the equation of the tangent to the curve which is parallel to the line. Okay, so first what you do, find the slope of the line, because if you know the slope of the line, that will be the slope of the tangent. Yeah. So slope of the line, if you know the formula minus b by a, you can do that. Sorry, minus a by b, you can do that. Or you can keep it in terms of y equals mx plus c and you can do it. I mean, whichever way you feel comfortable, you guys can do that. Yeah. So here we can write 2y is equal to 4x plus 5, right? Or you can say y is equal to 4 by 2 into x plus 5 by 2. Or y is equal to 2x plus 5 by 2. So the slope of the line is going to be 2, correct? So m1 is equal to 2. Now, since the slope of the line is 2, the slope of the tangent is also equal to 2. That means what we can write now is y dash, calculate. Y dash is equal to 1 by 2 root 3x minus 2 into 3. Correct? Now, this value is equal to 2. Slope of the line is equal to the slope of the tangent, which is basically the derivative. So, we can write 2 is equal to 3 by 2 into root of 3x minus 2. Right? Now, the whole point what we are doing right now is to figure out the value of x and figure out the value of y. That's the whole point what we are doing. That means the objective of the question is that you already know the slope. You need the points to form the line, isn't it? Because x minus x1 is m into y, y minus y1 is m into x minus x1. M is already known. X1, y1 are unknown. And you're trying to calculate that x1 and y1. That is the whole point of the question. Fair enough? Now, with the help of that slope m, we can calculate the value of x here. Correct? Once you know the value of x, substituting that would give me a value of y. That's the method or what we are going to do here. Yeah. So substitute 4 by 3 is equal to 1 by root of 3x minus 2. Square on both the sides. 16 by 9 is equal to 1 by 3x minus 2. Cross multiply. You'll get 3x minus 2 is equal to 9 by 16. Take the 2 to the other side. Yeah. You get 3x is equal to 9 by 16 plus 2 or 9 plus 32 divided by 16. Correct? So 3x is equal to 9 plus 32. So this is going to be 41. Right? 41 by 16. Now 41 is a prime number, isn't it? So x is equal to 41 by 16 into 3, which is 48. X value is 41 by 48. Now we need to figure out the value of y. Substitute that x here. So you will get y is equal to root of 3 into 41 by 16 into 3 minus 2. 3 and 3 cancels. So root of 41 minus 32 by 16. 41 minus 32 is 9. Root of 9 by 16, which is equal to 3 by 4. So y value is 3 by 4. Now substitute y minus y1, or you know what you can do. Since it is parallel to this line, we can say that the equation of the line will be 4x minus 2y plus k is equal to 0. Or you can use y is equal to mx plus c, or any of the forms you can use. Alright, I'm just using this form. Put x value as 41 by 48, y value as that 3 by 4. So 4 into 41 by 48, 2 into 3 by 4 plus k is equal to 0. So 12 times 2 times. So k is equal to 3 by 2 minus 41 by 12. Yeah. 12 is the LCM. So 18 minus 41. Correct? So what we have now is you're going to get the value of k. Right? So the value of k is minus 23 divided by 12. So k is minus 23 divided by 12. So we'll substitute these values back in the equation. So the final answer is going to be 4x minus 2y minus 23 by 12 is equal to 0. Basically, line which is parallel. Understood? This is going to be the final answer to the 17th one. Now, we have done almost all the types of problems what you have in tangents and normals. Correct? You calculated the slope of tangent, slope of normal. The point which is on the graph, that also we completed. Lines parallel to the axis, correct? Or axis or parallel to another type of line also, another line also. And you calculated the slope of the tangent and normal. You found the equation of tangent and normal. So this pretty much completes the concept of tangents and normals in application of derivatives.